Right, question 7. The fuel consumption of a new model of car is being tested. In one trial, 50 cars chosen at a random were driven under identical condition and the distance x in kilometers. Cover on a liter of fuel are recorded. Okay, the result are give to following totals. Okay, so they give you the sum of x equal to 525, sum of x square equal to 5625. Okay, part 1. Calculate the unbiased estimates of the population mean and the standard deviation of the distance traveled on a liter of fuel. Okay, so part 1. So if you want to calculate the unbiased means, okay, will be equal to sum of x over n, right? 525 over 50, so you'll get 10.5. Okay, so unbiased estimates of variance. Okay, question asks you to find the standard deviation. You may find the variance first, depends on you. Okay, if your variance can be the exact value, the standard deviation can be exact value, you may use it for further calculation directly. You can get the square root. Okay. If this is not an exact value, but maybe it's better that you calculate the variance first, then you use the square root of variance, because you need to use the variance for further calculation, right? The exact value, right? So it's good that you use exact value, right? Okay, so this is the general formula that you that you use to calculate the variance. Okay, so once you have this, you may proceed to calculate the variance first. So the s square unbiased variance will be equal to about 2.2959. Okay, so if you can put in the fractional form, you put in fractional form. If cannot, you may at least put 4 to 5 decimal place, right, to cover the loss of the law of values. Okay, so this is for s square. Okay, so once you have the s square, so your radius will be your standard deviation will be equal to the square root of 2.2959, right? So square root of 2.2959 will be something like 1.52, something like that. Okay, so this is for the standard deviation. Right, so now part 2. Calculate the 94% of confidence interval for the mean distance traveled on the liter of fuel. Okay, so for part 2, okay, for part 2, 94% at the center, so you would find pz smaller than z will be equal to 0.97. Okay, so 33 at the side. So 0.97, you should get z equal to about 97 1.97. If I get what I will use 1.882, right? 1.882, because 1.881 and 1.882 and 1.81 will be the same values for the probability. So try to get the maximum one. I will use the maximum one, right? So 1.882. Okay, so your confidence interval will be equal to, confidence limit will be equal to 10.5 plus minus, okay, 1.882 square root of 2.2959, okay, and 50. Okay, so by simplify this confidence limit, okay, you may get your 95% confidence interval is between 10.1 and 10.9. 10.1 and 10.9. Okay, so once you have this, then you can proceed to part 3. Okay, part 3, calculate the width of the 94% confidence interval, right? So for the width, you may use 2 times 1.882, just now the square root s square over n, right? So square root s square over n, so you should get 0.806, right? This one, the unit is what? Unit is kilometer, right? So the width is 0.806 kilometer, right? 3 SF, the width, part 3. So for part 4, okay, a second random sample of 50 cars, still the 50 cars, and 94% confidence interval is calculated using the sample value obtained. Okay, find the probability that neither, okay, confidence interval contain mean. Okay, neither mean, both also not contain mean. So the probability that not contain mean is what? For first one, right, 94% contain mean. So not contain mean means 0.06. Okay, so first. So for the second sample, also not contain, neither not contain, also 0.06. So both of them are not contain means 0.06 multiply 0.06. Right, so you should get the answer at the end 0.0036. Right, so this is the probability that neither of them contain in the confidence interval contain mean 0.0036. Okay, so this is for question 7. Now we proceed to question 8. Okay, for question 8, the result X of a stress test on a matter is known to be normal distributed with the mean mu and the standard deviation 1.3. It is required to have 95% confidence interval. Okay, for the mean, with a width of less than 2.0, find the smallest value numbers, okay, tested needed to achieve this. Okay, so for this question, normal distributed. Okay, so this question, smaller number of tests needed. This question never mentioned about the random sample, but normally this kind of question will be need to determine the sample size, okay, number of tests, okay. But if this is a standard question in your CIE, normally they will mention. If not, you need to recognize, okay, when you have the confidence interval, normally you need to do the sampling, because this sampling and estimation is together one, cannot run away. Okay, so for this question, you may have a distribution, the sample, okay, mean, and you have 1.3 square over n. Okay, so the population mean draw from the sample mean, sample variance. The population variance draw from the sample variance. Okay, so for the width 95 confidence interval, so you have z equal to 1.96. So the confidence interval, the width confidence interval, the width will be equal to 2 times 1.96 and square root of 1.3 square over n. Okay, so by simplify this, you should able to get a this this is the width smaller than 2, right? The width must be smaller than 2. Okay, so you can simplify this. Okay, you may get a square root n at the end larger than 2.548. Okay, 2.548. Okay, so by this you should get n larger than 6.67, and this is a random numbers. Is a number integer, so your n should be smallest will be equal to 7. This for question 8, right? So today we will stop until question 8. Okay, same things, I will post one question for you to as an assignment. Okay, so next part we will proceed to confidence interval for the population proportional. Okay, the proportion of the population, right? So case 1, 2, 3 are for the confidence intervals, limits. Okay, so forward and backward calculation. So today we stop here, and Friday we will continue with the mechanics. Okay, thanks.